Okay. Okay, so Kiki, selamat petang. So, okay, so before we continue with some discussion on topic of integration, may I test you with one simple question of differentiation using first principle? Just one simple question.
Okay.
Okay. Ibu, screen. Okay. Okay, Kiki, can you please read for me what you see on the screen here right now?
Hi there.
Okay, good. So, before we continue with the discussion of integration for this afternoon, I'll just give you one simple question of differentiation using first principle, and just to see the progress whether our previous discussion really works and help you, or might be we need a little bit we call discussion or repair on that discussion on this question here. Okay, so this is y equal to square root of x. Find dy dx using first principle. Okay, so Kiki, how many, how long that you need to solve this? 5 minutes, 10 minutes? Okay, how long that you need to solve this? 5 minutes, 10 minutes?
5-10 minutes.
Okay,
10
10 minutes.
minutes.
Okay, start now.
You can present the screen.
Pardon?
You can present your slide, your
Oh,
PowerPoint.
wait. Uh, Sekejap. Okay, Kiki, can you see this question then?
Yes, sure.
Y equal to?
Square root x.
Oh, square root of x. Okay, find dy dx using first principle. Okay, start now. Okay, Kiki, just inform me. Tell me once you finish your recall, solve the question.
Teacher done.
You're done.
Yeah.
Okay. So, y equal to square root of x, which is x power of half. So then dy dx equal to half, bring to the front here, 1 over 2x, half minus 1, negative 1 over 2. Differentiate x, it give you 1 here. So it is 1 over 2 square root of x. What did I say about this before?
Reference.
Reference, good. So now, limit of h approaching to 0. Have you asked your teacher about this?
Yes, teacher. She said can use.
Can use even in the examination.
Yeah.
Okay, good, clear. So now, limit of fx plus h minus fx divided by h. So then, limit of h approaching to 0, square root of x plus h minus square root of x divided by h. So in this case, we are referring to the numerator. So we need to multiply with the denominator conjugate of this square root of x plus h plus square root of x divided by square root of x plus h plus square root of x. Okay, you make your own checking. H approaching to 0. Okay, so this multiplied with this, I give you x plus h. And because we are multiplying with the conjugate, so which I think that you know what's the result of this. So it's minus square root of x times square root of x, which is x here. And then divide by h. And 1 over square root of x plus h plus square root of x. Okay, so then if we open up the bracket of this, open up the bracket. So x minus x, then h my times with 1 here. So h divided by h. So we get 1 over square root of x plus h plus square root of x. Okay, okay, for this h and this h has got nothing to do with this we call order or instruction, because we just divide the h by itself first, but then we still have another h waiting here. Then once we use this instruction, limit h approaching to 0, so once we substitute h with 0 here, okay, this and this and this, so h approaching to 0. Finally, once we use the instruction, we don't need to rewrite this again. Simply come up with square root of x plus square root of x. So 1 over square root of x plus 2 square root of x, it gives you 2 square root of x. Okay. How's it? Exactly same as yours?
Teacher, I send you mine already.
Oh, he sent the recall the picture. Okay. Hopefully that it recall remain in your mind even after the SPM. So you mereka bos harap boleh ingat sampai lama-lama sikit lah. Okay, sampai bila-bila. Okay, now for integration, in which part that you want me to explain. I'm not going to explain the whole topic from the beginning until the end, but then you just give me the idea which part that you really need a treatment and
Teacher, application of integration. Like that day you
application.
do for differentiation, right? Like that, but for
Okay.
integration.
Application of integration, which I think that to find an area and volume, right?
Ah, yes.
Okay. So now let's say uh, given to you y equal to 2x minus 1. Okay. So let's say if we sketch this, this is a linear. So when x equal to 0, y equal to, when x equal to 0, y equal to negative 1. When y equal to 0, if we make it equal to 0 here, then x equal to 2x minus 1 equal to 0, then 2x equal to 1, x equal to 1 over 2. So x equal to 1 over 2. So 0, negative 1. 0, negative 1, somewhere around here. And then half and 0, somewhere around here. So then this is the graph for y equal to 2x minus 1. Okay, let's say if the question wants you to find integral from 1 until 3 of the function of 2x minus 1 dx. Okay. um, Kiki, integral of 2x minus 1 dx from x equal to 1 until x equal to 3. Uh, x equal to 1. Are we talking about this point? X equal to 1. Are we talking about this point? This coordinate?
Yeah.
No.
Yeah. Wait.
What about here?
No, no,
No. Then here.
no.
What about here? X equal to 1.
No, yeah, it's that one.
Okay, that one. Okay. So this x equal to 1. Okay. X equal to 1. And then until x equal to 3. Okay. So then integral of this, we call to find an area. Find an area. This is the let's call the linear graph of y equal to 2x minus 1. And then we integrate from 1 until 3. Okay, actually that for this process, we are going to find an area where is we call surrounding by this line of x to x minus 1, x-axis, and also x equal to 1 until x equal to 3. Okay, so for this one here now, area for integral of 2x minus 1 dx from x equal to 1 until x equal to 3. So we are going to integrate this 2x squared divided by 2 minus x from 1 until 3. Okay, so then 2 divided by 2, then we get x squared minus x from 1 until 3. Then here we are going to, as we know that integral of fx dx from x equal to a until x equal to b is actually integral of this. It's going to give you capital letter of f with the variable of b first minus f a. Okay, so for this we are going to substitute x with 3 into an x of this, where the first is 3 square minus 3 minus, look at this, minus, and then x equal to 1, 1 cube minus 1. Okay, so now we get 3 square equal to 9 minus 3 and 1 Okay, 1 cube is 1. 1 minus 1 equal to 0. So minus 0 equal to 6 centimeter square, because we are talking about area. Area between the function or the line with the x-axis. Okay, and also we have this border of x equal to 1 until x equal to 3. Okay, another example, if I have y equal to x squared, can you please guide for me how's the graph, how is shape of graph of y equal to x squared? Okay, hello.
Yes, teacher.
Okay, can you please tell me how's the shape of y equal to x squared?
It's
X square we call classified as
quadratic
quadratic. Okay, how's the shape of the graph?
U shape.
U shape. U shape if the coefficient of x square, which is a here, greater than 0 is a what we call U shape or smile, and if a less than 0 is a set graph, which is negative. Okay, so the coefficient of x square a here equal to 1. 1 greater than or less than 0?
Greater than 0.
Greater than 0. So, and then y equal to x squared. When x equal to 0, y equal to
0.
0. When x equal to 1, y equal to
1.
when x equal to 2, y equal to
4.
4. Okay, is double. Okay, according to the formula, is x squared here. So then you will get the graph will be something like this. Okay, so now this is y equal to x squared. So if you like to find an area between this function or curve with the x-axis, a integral of from 0 until 3, the function of y dx, and then y in this question here now, y equal to x squared from 0 until 3. So we write down x squared dx. Okay, so from 0 until 3. Now, this is the area that we're talking about. Okay, so integrate this, it give you x cubed. Okay, integral of x to the power of n dx equal to x to the power of
N plus 1 over N plus 1.
n plus 1 divided by n plus 1 plus
Plus
c. Good. Okay, so 2, then 2 plus 1 equal to 3. Is that all?
over 3 plus C.
Over 3 plus c. Okay, plus c. But because with this, we have the limit of x a to b, 0 until 3. So we don't need c here. Okay, we straightly put them in bracket with x equal to 0 until x equal to 3. Then x equal to 3, b come first. So we substitute here 3 cubed divided by 3 minus x equal to 0. 0 cubed divided by 3. Okay, 0 cubed, 0 cubed is 0, 0 by 3 is also 0. So then 3 cubed, okay, 3 cubed
9.
equal to
27.
3 cubed 27 divided by 3,
9.
9 centimeter square. Okay, centimeter or might be unit square, because we did not know what is a unit, centimeter or meter. We choose unit square. Okay, so this is the area we call between the function or the graph with the x-axis from x equal to 0 until x equal to 3. Okay, let's say if I have y equal to x squared and then y equal to, let me think of something, 2x minus 2. Okay, let's try. When x equal to 0, when x equal to 0, y equal to negative 2. Okay, I'll try to make some graph something like this. Mm, plus 2. When x equal to, okay, when x equal to 0, y equal to 2, and y equal to 2. So when y equal to 0, when y equal to 0, make it equal to 0, then we get negative, and then divide by 2 become negative 1, x negative 1. Okay, so okay, because I recall thinking of a function spontaneously. Again, okay. So firstly, let's say this is the graph given to you. um, 2x plus 4. Okay. So when x equal to 0, when x equal to 0, 2 times 0 equal to 0, then y equal to 4. And then when y equal to 0, so that 2x plus 4 equal to 0, then 2x equal to negative 4, then x equal to negative 4 divided by 2, negative 2. So x equal to negative 2. So negative 0 and 4 above here, and then negative 2, 0 somewhere around here, negative 2, 0 and 4. Okay. And then y equal to x squared. This is y equal to 2x plus 4, and this is y equal to x squared. Okay, so let's say the question wants you to find an area, find an area bounded by the function of y equal to x squared, y equal to 2x plus 4, and y axis. Okay, so Kiki, if this is the question, find an area bounded by the curve of y equal to x squared, y equal to 2x plus 4 and y-axis. Which area that we're talking about? Are we talking about this area?
No.
This area?
No.
This area?
No.
This area? No.
No.
This area?
Yes. Yes.
Okay. So, because it bounded by y equal to x squared, y equal to 2x plus 4, and y-axis. So, this is the area. But before that, we need to clarify what is the intersection point between these two functions, because it's gonna give you the value of x here. Okay, in that case, we are going to, let's say this is y1 and y2. This intersection point actually shared, that we call this intersection point is a coordinate of x and y. Okay, let's say I put it as a p. So this we call coordinate of p, x, y intersection between these two graphs, meaning that this value of x and y shared by these two graphs, y equal to x squared and also y equal to 2x plus 4. So we need to find this intersection point first. So make it as y1 equal to y2. So we got x squared equal to x squared equal to 2x plus 4. Okay, then we get x squared minus 2x minus 4 equal to 0. Okay, so which I think that for this kind of, for this, is impossible for me to factorize this because, okay, let's use, if possible, negative b plus minus square root of b squared minus 4ac divided by 2a. Negative b is negative 2 plus minus square root of negative 2 squared minus 4a, which is 1 here, and c equal to negative 4 divided by 2a. So negative and negative positive plus minus square root of 2 square equal to 4, negative and negative positive, 4 square equal to 16 divided by 2. Okay. uh, 2 plus minus square root of 20 divided by 2. Square root of 20 equal to square root of 4 times 5. Okay, from the rule of square root of a times b equal to square root of a multiplied with square root of b. So 20 equal to square root of 4 times 5, square root of 4 times square root of 5, where square root of 4 equal to 2 times square root of 5. Okay, so this, okay, 2 plus minus, which is 2 plus 2 square root of 5 divided by 2, and also 2 minus 2 square root of 5 divided by 2. Okay, so in this one question, there are combination of many discipline of topic mathematics that we call discuss in one question here. Okay, so we got 2 here, we got 2 here, we got 2. So 2 and these 2 divided by 2 equal to 1. And then also 2 and these 2 divided by 2. So what is the value of x here now? Okay, hello?
Yes, Chuck.
Okay, we got 2 and 2 here divided by 2. Then 1 plus 1 third 5. 2 habis. And 2 and these 2 divided by 2. So what is the value of x here now?
0.
2 divided by 2.
1. Wait,
1.
wait. 1 plus
Haha.
5. Third 5.
1 plus third 5. And another one?
1 minus third 5.
Okay. So how I'm going to write this? Um, maybe it's not suitable to recall continue this with 1 plus 5 is a decimal, but at least can you get the idea of this?
Yes, teacher.
Okay, I think of another question which I think that make it also make it simpler.
Okay.
Let's say y1 equal to x squared and y2 equal to mm, square root of x. Make it easier. Okay. Okay, y equal to x squared is a curve, something like this. Okay, and then y equal to square root of x. Start from here. This is y equal to x squared and y equal to square root of x. Kiki, square root function, is this part in your part of the syllabus in we call SPM?
Square root function.
Yeah.
I think
Yes or
so.
no?
Yes.
Are they?
Yeah.
Okay, good. So now, Kiki, there is intersection point between the curve of y equal to x squared and y equal to square root of x. So we are going to find out what is the value of x here. Okay, as I told you that this intersection point, let's say P is a coordinate of xy. So value of x and y shared by both of this function, y equal to square root of x and y equal to x squared. So in that case, we may use this y1 equal to y2, x squared equal to square root of x. Okay, so
Yeah.
then let's say if I like to eliminate this square root and square left and right, it gives you x power 4 equal to x. Okay, so bring this x to the left side, x power 4 minus x equal to 0, and then factorize, take one of the x with a higher, we call the lowest value, the lowest degree, which is 1 here, factorize, and then x cubed minus 1 equal to 0. Again, x times x cubed equal to x power 4. X times negative 1 equal to negative x. Okay, so meaning here x equal to 0, x cubed minus 1 equal to 0, then x equal to 1. So clearly here, this is the coordinate of x equal to 0. So intersect between this curve y equal to x squared and y equal to x squared here, x squared of x, this is x equal to 1. Okay, from beginning of this question until here now, do you have any question?
No, teacher. So basically, we just want to find the coordinates, right?
Yeah, find the coordinate. Because, okay, find the coordinate because if the question is find an area bounded by the curve of y equal to x squared and y equal to square root of x, uh, find an area bounded by the curve of y equal to x squared and y equal to square root of x. Okay, if this is the question, where is the area that I'm talking about? Are we talking about this area,
No.
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 this area?
Yes.
Is this the one?
Yeah.
Okay, good. Now, kita dah tentukan dah, we determine the area that bounded by these two function, y equal to x squared and y equal to square root of x. So this is the one. But before that, um, The reason that we need to find x, the intersection point of this, especially x, because um, we are going to area, we are going to use the integral of fx dx minus integral of fx dx. Okay, we got these two, but then we need to clarify fx dx minus integral of fx dx, which come first. Okay, so as we know that from the previous example, when we integrate this function, it will give you an area between the curve and x-axis. Okay, between the curve and x-axis. So now, what about this? Uh, if I integrate on the look at the graph, because this is the area, this is the area. So the graph above come first. Okay, integral of, okay, the graph above represent by
Y equals to square root x.
y equal to square root of x. Okay, so um y equal to square root of x dx minus integral the next function, which is x square dx. Okay, um the first of the integral of square root of x dx, it will give you an area between the curve and x-axis. And we just stop until here because we already, okay, let's say starting from 0 until 1. From 0 until 1. Okay, so integral of this is going to give you an area between the curve of y equal to square. What happened?
Actually, my internet is bad. But now it's better.
Okay, right. I need to
Present again.
no, not restart, but then make a recording again. I still record, okay. Okay, so the whole area minus the area down here. So what's left?
The purple area.
The purple area in between, right?
Yeah.
Okay, so that's why we, when it comes to this question, better if we can, so we call sketch the graph. So at that area, we call kita boleh tentukan, we can determine which graph that above the other graph. If I make it something like this, integral of x squared dx minus integral of square root of x dx. So the graph below here minus the graph the whole of this area, you will get negative because kawasannya kecil tolak kawasan keseluruhannya besar. Okay, but then when it comes to this, is a whole area minus the small area yang bawah below this, then you get this. So then, integral of x power of half dx equal to
And 1/2x plus
1 over 2.
x plus c.
Okay, it's just like something like this. X power of half plus 1 divided by 1
And
over 2 plus 1
3
plus
over 3.
c. Okay, but then we don't need c here because we have the limit of x 0 until 1. So we don't need c here. A half plus 1 equal to
3 over 2.
3 over 2. Bring above and become
2 over 3.
2 over 3 x power of 3 over 2. From 0 until 1 minus, and this is x 2 plus 1,
3.
3 divided by 3 from 0 until 1.
Mm.
Okay, so it's time for us to substitute the value of x with 1 first. This one here into this equation. Okay, x equal to 1. 1 power of 3 over 2. Okay,
Yeah. 2 over 3.
2 over 3. No, before that. Do you know how to write this? I call a power of m divided by n.
Yes.
How is it?
Square root
Square root of
n
n
a
a to the power of m. Okay, so this considered as the power here, and then this is n root, the square root of n here. Okay, so then x equal to 1. 1 power of 2 of 2 is still 1 times 2 over 3, 2 over 3 minus x equal to 0, 0 minus this one 1 cube over 3, 1 over 3 minus 0. Okay, so 2 over 3 minus 1 over 3.
1 over 3.
1 over 3 unit square. Okay, I'll try to find out question that's similar to this from the My E textbook. So then I wanted you to test yourself for this. Sekejap. Sekejap. Integral of a until by dx. Okay. Y equal to 2x squared minus 6x. I'll give you around 5 to 10 minutes for you to test and see how is it progress. Can we?
So I have to
Okay, have to what?
do what, like what?
Okay, find an area between. Okay, find area between this curve and x-axis. Okay, boleh?
Okay.
Okay, start now.
So if you get area that is negative, you just make it positive, right?
Mhm.
Let me send you the answer.
Because one of the area is below x-axis, another one is above x-axis, am I right?
Yeah.
Okay.
Okay. So I send you already.
Okay, the first area, the area -9, meaning that we call the solution for the area below the x-axis. Another one,
Teacher,
yeah, just send another one.
I sent one only.
Okay, never mind. I'm gonna also go to yeah. So you make your own checking. Just let me know if any of these we call solar explanation or solution that different from yours. Then we try to figure out together. Okay, so now uh, is a quadratic x square. So the graph and the coefficient of x squared is 2, where a equal to 2, which is greater than 0, and the graph is something like this. Okay, now y equal to 2x squared minus 6x, make it equal to 0. Y equal to 0. So then factorize, we got 2 and 6 is a even numbers. And x squared with x, take out one of the x here. So then 2x times x minus 3 equal to 0. 2x times x, 2x squared, 2x times negative 3, negative 6x. So then x equal to 0 according to this, and also x minus 3 equal to 0, then x equal to 3. So 0, 0, and 3, something like this. Okay. Find an area between the y and also x-axis, which I think that we are talking about only this one, right? Okay.
Yeah,
Okay. So this area, which is integral of 2x squared minus 6x dx from 0 until 3. So then we call for this 2x. Okay, integrate this 2x cubed divided by 3 minus 6x squared divided by 2 from 0 until 3. Okay, and then uh, 6 divided by 2 equal to 3. Then you get 2x divided by 3, 2x cubed divided by 3 minus 3x squared from 0 until 3 equal to, okay, substitute 3 first, then you get 2, 3 cubed divided by 3 minus 3 times 3 squared minus 0. Substitute x0 here, 0. Substitute x0 here, 0. So which I think that we can just simply make it equal minus 0 here. So 3 cubed, 27. 27 divided by 3 equal to 9. 9 times 2 equal to 18 minus uh, did I make a mistake here? x squared, x cubed over 3, x cubed over 3, and then 6x squared over 2. 6 divided by 2 equal to 3, and x squared equal to x squared. Kiki, do you find any mistake here?
No, teacher. Because this is my answer, so 18 minus 27. Right.
Pardon?
18 minus 27.
Oh, 18 minus 37. Yes, yes, because it's below the x-axis. So this graph considered as negative, but not the area is negative, but then negative stand for the area below the x-axis. Okay, sorry, sir, thank you. Okay, so 3 cubed 27, 27 divided by 3 equal to 9, 9 times 2 equal to 18, and this square 9, 9 times 3, 27 equal to negative 9. Okay, negative stands for the location of the area is either above x-axis or below x-axis. So the graph here now is below x-axis, so that we have negative, but then in some books they simply write down the area is 9 unit square. Okay, or sometimes they simply use they use this sign. Have you heard about this? Have you look at this sign before?
Modulus?
Yes, absolute values, or we call this as a modulus. Okay, so if we have this, okay, here, here, and also here, whatever negative value, when we have this absolute value sign here, automatically it becomes positive or just 9. So the area is 9 unit square. Okay. Okay, so let's say if I give you find an area bounded by the curve of function y equal to x cubed mm, minus 5x squared plus 6x and x axis. Okay, Kiki, another 5 minutes. Try on this.
Okay. Sure.
Yeah.
Uh, I don't know how to do this because, like, yeah.
Okay, it's okay. Okay, it's okay. Okay, now, this is cubic. Have you heard about cubic function?
Yes.
Yes. Okay. Y equal to x cubed minus 5x squared plus 6x. Let's say if we make it equal to 0. Okay. Uh, there we go. Or every single term. One, two, three. All the terms will have an x. Okay, x cubed, x squared, and x. So the least is x of 1. So take out x, and then we get x squared minus 5x plus 6. Make it equal to 0. Okay, now, is it possible for me to, or maybe possible for us to factorize this to get another two linear vector?
Yes.
Okay, x minus 2 and x minus 3 equal to 0. Get it? Okay, now if I sketch this, okay, because 1, 2, 3, we got three linear vectors. Okay, from here, we can say that x equal to 0, x minus 2 equal to 0, and x minus 3 equal to 0, then x equal to 2, and x equal to 3. Okay, so from here, we get three value of different value of x. 1, 2, 3. X equal to 0, x equal to 2, and x equal to 3. The graph may be something like this. It's either this or this one. So which one? 1 or 2? Which of this is the graph for this function? Okay, I have no idea. Let's say if I come up with a value of x, say let's say x equal to 1. When x equal to 1, 1 cube, 1 cube minus 5, 1 square plus 6 times 1. Okay, 1 and then 5 plus 6. So 6 plus 1 equal to 7. 7 minus 5 equal to 2. So when x equal to 1, y equal to 2. So the graph will be something like this. There you go. Okay, Kiki, are you still with me?
Yes, teacher.
Okay. Now, this is a graph. Okay. Up here, down again. Intersect at x equal to 0, x equal to 2, and x equal to 3. So now, find an area bounded by the curve of y equal to x cubed minus 5x squared plus 6x and x-axis. So the uh, area number 1 and area number 2. So just name it this one as an A and this is B. So the whole area is A1, A plus with B. Okay, area of A for this integral of the function of fxy equal to this x cubed minus 5x squared plus 6x respect to the x, and the limit is
0 to 2.
0 to 2. Good. 0 until 2 plus with, because we are dealing with the same function, again we repeat x cubed minus 5x squared plus 6x respect to the x, and the limit is from
2 to 3.
2 to 3. 2 to 3. Okay. Okay. Now we are going to, okay, Kiki, you may solve this in one row as I write on this screen right now, or you may find the we call the area of A first, and then find the area of B, and then you just sum. We call the area of A and B at the end. So what I'm trying to say is, okay, let's say if you separate the solution, find A first. Okay, the area of A, integral of x cubed minus 5x squared plus 6x dx from 0 until 2. And then x power 4 over 4 minus 5, okay, sorry, plus minus 5x cubed divided by 3, and then plus 6x squared over 2 from 0 until 2. Okay, 6 divided by 2 equal to 3. So this is 3x squared, x 4 over 4, 5x cubed over 3, and 3x squared. So substitute first x equal to 2. 2 power of 4 divided by 4 minus 5, 2 cubed divided by 3 plus 3, 2 squared. And then minus substitute x with 0, 0, 0, 0, and it give you all 0. Okay. Okay, class. Okay. I think that let me show you what we call separately. Find A first, and then we will find B. Dapat jawapan dua-dua, kita just tambah kemudian. Okay, we add the value. We call the area later. Okay, so what about this? 2 power 4. 2, 4, 8, 16. 16 divided by 4, 4. 2 cube. 2 cube equal to 8. 8 times 5 equal to 40. Minus 40 divided by 3. And then plus with 2 square equal to 4. 4 times 3 equal to 12. Okay, 4 plus 12 equal to 16. 16 minus 40 over 3.
8 over 3.
8 over 3. Okay, how is it? 16 minus 40 over 3. How we deal with this?
Denominator.
Okay,
Let's
this is integer. This is fraction. So we change into fraction. 16 multiplied with 3 is 48 over 3. 48 divided by 3 equal to
16.
16. Okay, so 48 over 3 minus 40 over 3, then we get 8 over 3 unit square. Okay, this is an area of A. Okay, the first area. And then B equal to integral of x cubed minus 5x squared plus 6x dx from 2 until 3. Okay, because we can see clearly that this area below the x-axis, you will get at the end here, the area of B is negative. What did I tell you just now about negative?
Modulus.
Modulus. Okay, no. Modulus, if we change the negative to positive. What is negative in this situation?
The area below the.
It has area below the x-axis. So then we come up with negative. Okay. So then here now, x power 4 divided by 4 minus 5x cubed divided by 3 plus 6x squared over 2 from 2 until 3, and 6 divided by 2 equal to 3 here. Okay, begin with x equal to 3. 3 power of 4 over 4 minus 5, 3 cubed divided by 3 plus 3 squared. minus, and then 2. 2 power 4 divided by 4 minus 5. 2 cube divided by 3 plus 3, 2 squared. Okay. Okay. Find this for me. 4, 4, 9, 7, 8, 4 minus. Okay, you may use your calculator.
Negative 5 over 12. The whole thing minus.
Wait. Okay, the whole thing minus
Negative 5 over 12.
negative 5 over
Over
12.
12.
Is it? This is one?
Yeah. Yeah.
Okay. So you may, okay, if this is the answer, you write down the statement, the area of B is 5 over 12. Okay. Or you may simply come out with a sign of modulus at every single step here and write down as 5 over 12. Okay.
Then we must plus.
Huh?
Take A plus B. So 8 over 3 plus 5
Okay.
over.
Okay. So, Kiki, we call please be careful if this, okay? If your answers end with negative 5 over 12, you write a statement. The area of B is 5 over 12. Or you come up with a sign of modulus and simply write down this as a 5 over 12 without a statement. Okay, so now the area, which is A plus B, equal to 8 over 3 plus 5 over 12. So we are going to, we call equalize the denominator 2 and 12. So 3 times 4 and 8 times 4. 3 times 4 equal to 12. So 8 times 4,
32.
32 minus or plus 5.
37 over 12.
37 over 12. Unit is an area. So unit
Square.
square. There you go. Boleh, eh?
Okay, teacher.
Okay. I'll give you 2 questions, and that is we call at least a closing question for this afternoon. Okay, question
Okay.
1. Okay. Okay. Two questions. Hello, Kiki.
Yes, teacher.
Okay.
Doing.
Two questions for recall for apa, to close the discussion for this afternoon. Boleh nampak kan?
Boleh.
Okay, right.
Teacher, y
Hmm?
equals to x cube minus x square minus 5x.
Y equal to x cube minus x square minus 5x.
Okay, minus. Yeah, I already do the first question,
Okay, you're
but
done
I'm
first.
stuck at the second one.
You complete question number one, but then you stuck at
Question two.
question two.
Yeah.
Okay. Okay, right. Question one. Okay, y equal to x squared and y equal to x. So the graph is something like this. Okay, this is y equal to x squared, and then another graph. This is y equal to an x. Okay, okay. So now we are going to find an area between the y equal to x squared and y equal to an x. So this is the area. But before that, we need to find the limit. And the limit, first, we can see clearly the intersection point between these two graphs at x equal to 0, y equal to 0 at origin point here. Okay, here. But then what about this? So then we, okay, because this coordinate intersection point, which is coordinate that's shared by both of the function. So we come up with y1 equal to y2, x squared equal to an x. So then x squared minus x equal to 0, then x minus 1 equal to 0. So then x equal to 0 and x equal to 1. So again, this is x equal to 1. So, okay, now to find an area between these two functions, sorry, okay, to find an area between these two functions, we need to clarify where the area is. Where is the area? And then which in, okay, this is the area. According to this is the area. So we got y1 and y2. Okay, from the Lego graph, linear graph, and also the curve. So in this area, this graph above the other one. So the above one represent, okay,
Yeah.
the above function. Okay, this is the area. This is the area. Macam karipap ni.
Y,
Okay,
y equals to x.
y equal to x. Okay, y equal to x. Above and then below is y equal to x squared. Okay, because the first we call integral. The first integral will give you the whole area. Integral of, if we choose y equal to an x dx from 0 until 1, it will give you the area, the whole area, something like this. And then minus integral of x squared dx also from 0 until 1, and this area is the area between the curve and x-axis. Okay, if the whole area segitiga ni minus the area, the small area, the half part of the area between the curve and the x-axis, you will get the area that we're looking for in between here. So again, from this picture, we call, kita boleh tentukan which area, which function that above of the other function. So then, integrate this, it gives you x squared over 2 from 0 until 1 minus x cubed divided by 3 from 0 until 1. So then 1 square is 1 over 2 minus 0 minus, 1 cube, 1 over 3 minus 0. So it is now 1 over 2. This is 0, this is 0. So 1 over 2 minus 1 over 3 equal to 6. 2 times 3, 3 times 2. So 3 minus 2 equal to 1 over 6 unit square. Okay, you get exactly same as mine?
Yes, teacher.
Okay, question number 2. X cubed minus x squared minus 5x. Oh, dah habis dah, sorry. Dah habis page. Okay, saya padamkan yang ni dulu. Okay. Okay, so question number 2, y equal to x cubed minus x squared minus 5x, make it equal to 0. Take one of the x, each of these, so x squared minus x squared minus x minus 5 equal to 0. Factorize this. Okay. Oh, okay. I make one mistake here. Never mind. Okay, you try it later. I'll change the figure dan lebih mudah. Okay, I'll change it into 6. Sorry, 6. Okay, 6. So then x and x. So the dominant is negative. So negative 3 and plus 2. X times x, x squared. X times negative 3 and 2, negative 3 plus 2, negative 1. 2 times negative 3 equal to negative 6. Sorry, it's supposed to be 6. Okay, so now from here, we find that there are 3 value of x here. X equal to 0 and x plus 2 equal to 0 and x minus 3 equal to 0. X equal to negative 2 and x equal to 3. So negative 2, 0, and 3. Okay, the graph will be something like this or this. Which one? Let's try. Let's say x equal to between negative 2 and 0, negative 1. So substitute here, negative 1 cube minus negative 1 square minus 6 times negative 1. Negative 1 cube is negative 1. Negative 1 square is 1 minus negative 1. And 6 times negative 6 times negative 1 equal to positive 6. So 6 minus 2 equal to 4. X equal to negative 1, y equal to 4 above here. So again, the graph is something like this. There you go. Okay. So now, again, okay, the area,
Okay.
let's say I make this as an A and B. A plus B, and this integral of x cubed minus x squared minus 6x dx from negative 2 until 0 plus with integral of from 0 until 3 x cubed minus x squared minus 6x dx. Okay, so now x power 4 divided by 4 minus x cubed over 3 minus 6x squared over 2, so become 3x. Negative 2 until 0 plus with the same With this one here now, x4 over 4 minus x cubed over 3 minus 3x from 0 until 3. This is negative 2. So, okay, the first we substitute with 0. 0, 0, 0 is all 0. Minus, okay, negative 2 power 4. 2, 4, 8, 16. Negative power 4 is 16. Okay, 16 divided by 4 equal to 4. And then negative 2 cube equal to negative 8. Negative, negative become positive. Plus 8 over 3. Negative 2 times negative 3 equal to 6. Okay, this is for A, and plus with for B, 3 power 4, 3, 9, 27, 81. 81 over 4, and 3 cube, 27 divided by 3, minus 9, and 3 square equal to 9. And because we have 0 here, minus with 0. So, okay, which I think that for the last part here, I leave it to you to to find the solution by yourself. Boleh eh?
Okay, teacher, boleh.
Okay. So, okay, for today, which I think that I have covered a few questions on we call an area. So we're going to continue with the solution to find the volume of the graph of the area rotated 360 above the x-axis or y-axis in our next class.
Okay, teacher.
Okay, so that's all. Okay, take a rest, Vicky. Thank you. Bye.
Teacher.
Have a nice day.